Hey guys, welcome back to another video. My name is Roland and I'm your tutor. We're going to continue here with trig revision. We'll do a couple of examples and just enjoy it, sit back, relax, and do some decent learning here. Alright, so we start off with our first question here. Okay, let's determine without a calculator the following. Let me just write it out. So you've got cos 420 minus sine 225, cos minus 45 over tan of 315 degrees. What do you have to do? Well, you have to break it down into acute angles. How do we do that? Well, we'll go through it. You need to remember you've got your identity triangles to think about. If you can't remember them or if you don't know what I'm talking about, please make sure to go watch the previous videos. There's a great video, about 36 minutes long. It just explains all the basics that you need, starting from your basic triangles and explaining how to remember your 0, 30, 45, 60 and 90 degree angles. Let's use the reduction formula to express this trig ratio in terms of an acute angle. Let's rewrite the question. We have cos 420 minus sine 225 times by cos of negative 45 over tan of 315. We say cos of 360 plus 60 degrees, close our brackets, because 360 plus 60 gives you 420. We do something similar for sine, but we say 180 plus 45 degrees. And then we say cos of negative 45, because it's already an acute angle. We now do tan on the bottom. We say tan of 360 degrees minus 45 degrees. Alright, now that we've done our expansion, let's get rid of our obtuse angles and sit with our acute. We know that cos of 360 plus 60 puts you into the first quadrant. If you're not sure what that is, make sure to watch the previous video, but that is the quadrant where all angles are positive. Now you can see I've said in brackets I've got the negative sine 45, the sine where you have 180 plus 45 degrees, that actually takes you into the third quadrant. And there, only tan is positive, and that means that sine will be negative. Cos, as you can see, is positive 45 because it's in the fourth quadrant, because it's a negative angle moving down from 0 towards 270, meaning that the cos is positive. We then have tan being a negative, and then we move on. We now have cos 60 plus sine 45 cos 45 over negative tan 45. We use our special angles over here. Now step 2. Special angles, there we go. And we use them to simplify. Okay, so what is cos 60? If you can remember, cos 60 is a half. So that one you can just put straight down. You've got sine 45, which is 1 over root 2. Cos 45 is 1 over root 2. Multiply those two together and you get 1 over 2 in total. And on the bottom you've got minus 1. This tan of 45 is always going to be 1. You've now got a half plus a half on top. because 1 over root 2 times 1 over root 2 is a half. Now you've got a minus, so just put the minus on the left, open your brackets, and a half plus a half is 1. Right, and then you bring the minus in and you've got minus 1. Here we have prove as our next question. We're saying sine squared alpha minus tan alpha minus cos alpha times tan of alpha. Seems very confusing, but really it's not. We're saying that that's the left-hand side of the equation. I just didn't have enough space. We're saying that it is equal to cos squared alpha minus sine squared alpha. Here we have it over cos squared alpha. Alright, let's state our restrictions. If you have cos squared alpha on the base, you need to restrict if necessary, but it really doesn't have any restrictions. If it was tan, however, it would have a restriction at 90 degrees. Because tan at 90 is an asymptote, meaning that it cannot, the function of tan does not go through that 90 degree line. Alright, so let's start with our solution. Just making sure that we clarify what the equation is, so we don't make any mistakes. Okay, let's move on. Let's simplify the sides. Which side are we going to work on first, though? It's generally best to look at the left-hand side. If it's easy to work on it. Otherwise, look at the right. Whichever one's the easiest you start with. So we'll start with the left-hand side. We've got sine squared alpha minus, in brackets, tan alpha minus cos alpha. And then you've got multiplied by tan alpha plus cos alpha. Right, we can't do much to sine squared alpha. However, we've got the difference of squares essentially. So what do we do here? You put in brackets, we say tan alpha minus your cos alpha, and then square it out. There we go. That's a basic difference of squares. So now let's get rid of our signs. So we've got minus tan squared alpha. There we go. We now have plus cos squared alpha. What do you notice? You've got sine squared alpha plus cos squared alpha minus your tan squared alpha. What does the sine squared alpha plus cos squared alpha represent? Something important. We're not sure, as I've mentioned, go and watch the other videos before, but I'm also going to make a note on it here. So sine squared alpha plus cos squared alpha is equal to 1. Take good note of this. Putting this in a nice cloud so you don't forget. So essentially, your left-hand side is equal to 1 minus tan squared alpha. Now we could stop here, or we could turn tan into sine over cos, and then take 1 and the sine and put them both over cos, making cos squared minus sine squared over cos squared. We will see if we need to do that. So now let's do our right hand side. We've got cos squared alpha minus sine squared alpha over cos squared alpha. And what I literally just said is exactly what we have on the right hand side. So we could literally just have continued on our left hand side and turned it into our right hand side. That just already proves that we're correct. Okay, there we go. We pull the causes over the causes. With the sine over the cos, you can see it straight away. It's 1 minus tan squared alpha. There we go. So at least there's two methods that we've done so far. It's the same as tan squared alpha. In case you didn't realize that, yeah, sine alpha over cos alpha is actually tan alpha. So if you've got sine squared over cos squared, you're going to have tan squared. Take good note of that. That's a very basic one, but it's obviously very important as well. So you've got your answer is 1 minus tan squared alpha. And as you can see, that's exactly the same as what we had on the left-hand side. Cool. So our left-hand side is equal to our right-hand side. That's what we want to see. So now it's been proven. Now, are there any restrictions? Let me just write this out. We need to determine the restrictions. So the values of alpha for which any of the terms are undefined. Okay, so we need to determine the values of alpha for which any of the terms in the identity will be undefined. Let's see, cos squared alpha is equal to 0. Therefore, cos alpha is also equal to 0. See, as you take the square root of cos squared and you take the square root of 0, the answer remains 0. So just make notes, the square root of 0 is always going to be equal to 0. That's a solid algebraic expression there, or an algebraic process, I should say. So now we say that alpha is equal to 90 degrees or 270, because that if you understand how the cos graph works, at 90 and 270 the value will be 0. At 0 and 180 you'll have 1 and minus 1 respectively. Okay, so now let's consider the values of alpha for tan alpha. Remember what we said earlier? Tan is the one where you have undefined values at 90 degrees. Okay. Also, you should just remember these rules as basic rules to work from. It's very important that you actually remember them, because it kind of creates a nice list of roadmaps or rules for you to answer questions. So let's look at the identity. The identity is undefined for alpha when it's equal to 90 degrees plus k180. Now that's your general solution, the k180 part, for tan. So you'll have 90, and when any value of k and multiplied by 180 is within your set, so if you've got your limit set to negative 360 to positive 360, then you'll have to define certain values of k, and then with those values you'll calculate values of alpha, and then you'll be sorted. So the tangent function has asymptotes at 90 degrees and at 270 degrees. Okay, so at the value of k is equal to 1, you'd have 90 plus 180, which gives you 270. And there we have it, right below in the red. So, for an example, tan alpha, when k is equal to 0, we'll say alpha is equal to 90. When k is equal to 1, however, like we just mentioned, I just thought I'd write this one down for you. You've got 90 plus 1 times 180. If you sum those together, you get 270 degrees. And that meets our statement above. Easy game.